Yeah, so just by way of introduction, I've been involved in SBOMs actually for more than 10 years. I'm one of the co-leads for the SPDX SBOM standard, a format for SBOM similar to Cyclone DX. And I just wanted to thank Jan for teeing up the definition for SBOMs. That's one of the things I was thinking I'd have to cover, but I think you covered that extremely well. So I'm going to just jump into a couple of thoughts on web access to SBOM data. Um, I wanted to give you a little bit of context and background on the current state of SBOM standardization. And one of the things that I've been thinking about for a number of years is how do we make SBOM data access ubiquitous, easy to access, down to the browser level is one really good example. But wherever you are in the consumption or production of software, how do we make it easy to get accurate, verifiable data about the software that you're using? And I kind of broke it down into two different parts. The network access protocols, how do you discover, how do you securely access it? And once you get it, you need to have kind of a common vocabulary. And I have a couple of examples of existing work in this area, but more work needs to be done. So one of my primary reasons to bring this up to this particular group is I want to find out if there's interest in perhaps working on this either or both of these problems and moving this forward. So a little bit about the current state. CISA and NTIA refer to three different SBOM standards in their documentation. I think the SPDX and Cyclone DX are the two most popular ones currently. And they're primarily focused on metadata exchange, data about the products and the dependencies. We do have some collaboration going on between the SBOM standards. About every 6 months, I meet up with some folks from the Cyclone DX community, and we kind of make sure that we can interoperate on kind of the core elements, anyway, the most used elements. So that's something I definitely would encourage continuing on both standards to make sure that it's easy to interoperate and we don't cause too much pain to people that have to use both of these standards. Efforts are underway there's an OpenSSF SBOM Everywhere group that I participate in. They're creating a lot of best practices around the discovery of SBOM artifacts, how to name them, how to store them, and all some very, very good work. And there's also a CISA tooling work group that's making some good progress in that area as well. However, currently, I don't believe, and I'd love to be corrected and told I'm wrong on this, but there's no standard protocol for SBOM discovery and access. The other issue that we've run into is the granularity of SBOM data access of course I spelled it wrong, but is rather coarse, as in large chunks of data, and that can cause problems that I'll explain a little bit later. So there's a little bit of work to be done. So here's one thing I just wanted to describe where we are today and a kind of a possible future for SBOM access. Today, we have a number of producers of software, whether they're projects and open source, commercial software providers. And we actually are getting, I think, I've been seeing some surveys lately. I'm surprised at how much adoption we are getting in SBOMs. Of course, government regulations is a good catalyst for that. But we are seeing a lot of these documents being produced. But each of these are somewhat independent documents, and they have a huge amount of overlapping data because they describe their entire dependency tree. And in that description of the dependency tree, they're basically copying the same data over and over and over again. And there's, as I mentioned before, there's kind of no standard discovery protocol for the consumers to be able to find the data. So when I think about the future, one of the things I would like to do, and we're actually actively working on this in our next release of SPDX, is have much more granular access to the SBOM data. So rather than having everything duplicated in these SBOM documents, basically being able to address and reference and validate the integrity of what we call elements. And an element may be a package, it may be a file, it may be down to even a small snippet of code, and reference rather than copy. So it solves a lot of problems we have of duplication and inconsistencies in the data. And then the second aspect is having some kind of a discovery protocol. So in terms of discussion, well, I guess this just kind of repeats what I just said. reference not copy, element metadata provide. Oh, this one I forget to mention, which I think is important, is that the element metadata, if we can, the closer we can get it to the originator of the actual thing that's being produced, the more accurate it's going to be, or at least you know where the issues are. Right now, we have a situation where a lot of SBOMs are generated by SCA analysis tools, and they're not necessarily perfect. So if we had the originator say, okay, here's what I have, here's what I'm producing, and then the dependencies reference that information, we'll have a much more trustworthy and validatable SBOMs in the world. And then, of course, the last one is only transfer what you need, more efficient for that. So I kind of broke this into kind of almost two different proposals. One is working on the protocols. This is, by the way, is not my area of expertise, but I do work with some folks that are pretty good in this area. And I did want to reference one particular protocol that's out there already. It's going through the IETF process right now. It's pretty close to being accepted. It's RFC 9472. And it basically, the nice thing about this is it's somewhat agnostic to the format. It looks at the MIME type of what's being produced. And it's just a protocol for discovery all the way down to the devices. So if you have a hardware device on the internet, think Internet of Things, or it could be a piece of software on the internet. It supports discovery of not only the SBOM information, but the vulnerability information associated with that as well. And the only issue is that this is really applicable for the end user, the end devices. It doesn't really, it's not really as applicable if you're in the middle of the software supply chain. So, and there were two other protocols that I've been made aware of after I started pulling this information together, but they're very early in the proposal phase. So, and you guys may know of more work in this area than me. Like I mentioned, it's not my area of expertise. So here's a few different questions, I have for the group is, does it make sense to create a protocol? I would say not for just document discovery, but for element discovery that allows for us to be able to find and pull some of this SBOM information together, perhaps down to the actual browser, as we were talking about a little earlier. And if it does make sense, who's interested? Now, the alternative to this discovery mechanism is just to have some kind of a global registry. And this is kind of what we're doing today. You'll have, in fact, we have lots and lots of global registries. Usually where the software delivery artifacts are stored, the repositories of code, is where the SBOMs are stored as well. And of course, the challenge with that is there's a lot of them and there's no automated discovery of that. But that is an alternative to solve the same kind of a problem. Talk a little bit about, I think the other half of the problem is, if we have the protocol to find and communicate, we need to have a common vocabulary. And we've been thinking about this actually since the start of having the SBOM data specified in a way that supports linked data. So if you're not familiar with linked data, it's just a way of being able, to link the data about SBOMs across the internet in a verifiable, reliable way. And there's a couple of standards out there to support that. JSON LD is a very popular, I'd say relatively easy to use. And then RDF is a W3C standard that supports linked data for this. So within the SPDX community, we've been working on this actually from the very beginning. And we are going through a fairly major revision of it. Primarily, we used to use RDF to communicate at the document level. With 3.0, we're making things available down to a very small element level, which I think helps promote the vision that I mentioned earlier. It is a breaking change. It is probably the primary reason for the breaking change, but what's been driving that is the scalability of SBOMs. We have some contributors to the spec that are doing massive systems with millions and millions of packages and at a very, very high scale, and they need this kind of granularity to be able to make those systems work. So that work, I think we can leverage to making it scalable at internet scale as well. So, there's a little bit more information on this in terms of where the ontology is stored and the standards that it's in. And if you're interested in that, we can certainly discuss that a little bit more. So, the questions around the vocabulary is, first of all, should we have a common vocabulary for SBOMs? Is this a problem we're solving? Do we want to use some kind of a formal ontology language to describe this? There are a few standards out there that I'm particularly favorable to, but there may be alternatives as well. And should we start working on an ontology? And I will say that there has been some really good work in the Cyclone DX community of describing how the two vocabularies work to how they're similar vocabularies. So this isn't necessarily an exclusive SPDX proposal, but we can also have be able to correlate that to some of the similar terms that are being used in some of the other standards. So just something to tee up, something if you're interested in that, I would say this is the one I would definitely be interested in, perhaps a little bit more qualified to contribute to. It is something that we're working on in SPDX, but I'd be happy to broaden that out to a larger and more different standards communities if there's interest. So I believe that is it. I will stop sharing and